Hi everyone, today let's solve the problem number 735 asteroid collision, right? So what the question states here, we are given an array of integers. You can clearly see here, we are given an array of integer asteroids. So uh, what does the positive and the negative value within the this one, what do we call array indicate? So positive value means asteroid is going right. Positive value, just give me a second here. Yeah, positive value, these two are the positive values, right? Asteroid is going right. If we have the positive value, then asteroid is going right. If we have the negative value, suppose if we are considering -5, asteroid is going left, right? So if they are at the same speed, if they two meet, if they are of the same speed, if they two meet, then the smaller one explode. Then the far smaller one explode, right? So here basically, suppose if we have 4 and suppose if we have this one -4, both are equal, right? So if they're of the same speed and if they collide, if they are of the same speed and if they collide here, so right, if they collide, so basically both explode if they are equal, both explode if they are equal. If here in this case, if we have the value means if two of them meet, then smaller one, if one is greater and one is smaller, then the smaller one explodes. If two of them are equal, then the negative then the this one, what do we call, both explode basically. If we have -2, this will be considered actually within the absolute value, right? So this will be considered positive value itself, not the negative value. Negative value just indicates that it is what do we call, just asteroid is moving in the left direction, that's it. So basically this we will be considering within the this, it will be considered as an absolute value, right? So just keep this in mind. Here if we have 4 and 2, right, suppose we have 4, yeah, suppose we have 4 and -2, right? So let me delete this one. So let me take new here, 4 and -2. So if they are going with the same speed and if they collide somewhere, right, if they collide somewhere here, so what happens is, um, not collide, if both of them meet somewhere, right, then the smaller one explodes here in this case. So this will be absolute value and still this explodes basically, the smaller one, the value basically the value which is smaller basically explode. So here this one explodes, right? So I hope this one is simple, man. This one is clear, this one is simple to understand, man. See here, we have 5, 10 and -5. The 10 and -5 collide here. 10 and -5 collide, resulting in 10. 10 and -5 collide, resulting in 10, right? So because 5 is the smaller one, as I've said, so we have 5, 10 and -5. So 5 and 10, this is fine. First we'll go with 10 and -5 because both are so they both collide somewhere, right? They both meet or collide somewhere, and so this is absolute value, and the smaller one, if they meet, the smaller one, this one explodes, right? So this one explodes and only we are left with the 10. So the first value is also 5, that one also we need to display basically. So the output will be quite obviously 5 and 10, right? So I hope this part is clear, right? They have given us the wonderful examples just for the sake of understanding here, right? So explanation also they have given here, the 10 and -5 collide resulting in 10, the 5 and 10 never collide, the 5 and 10 never collide, right? So because both go right, both go right, right? So this is fine. So here in this case 8 and -8 we have, both are of the equal value, both are of the equal value. When 8 and -8 we have, so suppose this will go left and this will go right, and when they both are having the same value, so this will be absolute value, this is different, but I mean both are both will collide somewhere, and so here both will get this one, what do we call, um, so we have to both explode here basically. Sorry, I forgot the term explode itself. So here both explode, right? So this is fine. So we are left with the empty array here. The final one is 10, 2 and -5 we have. 10 2 and minus 5 we have. Let me delete this one. Yeah, 10 2 and minus 5 we have. First what happens, 2 and minus 5, 10 and 2 both goes right actually, right, both goes right. 2 and minus 5 we need to deal with, right? So here we have 2 and minus 5 both collide at certain this one place, right? So here in this case absolute value, this will get what do we call, this will get explode the smallest value. The smallest value is 2, so this will be absolute value will be considering, right? So this will be plus 5 itself. So here in this case 2 and 5 this will get collided, and here this explodes. The smallest value 2 will get exploded. Here we are left with the minus 5. That's what. And again now we have 10 and minus 5. 10 and minus 5, yeah, negative value still we have. This will go right and this will go left basically, right? So here somewhere they collide, and what happens, this is the value, what do we call, absolute value. Again the smaller one will collide basically, and we are left with only 10. So this 10 we will return as output, or we'll display this one as, we should display this one as output basically. Here in this case we got 10, which is equivalent to the output that they have given here, right? So here in this case I hope the three examples that they have given are completely clear. They have given us wonderful examples here just for the sake of understanding, right? I hope the question as well as the examples that they have given is completely clear. Next, what shall we do? Let's discuss the approach. Let's discuss the approach. So what is the approach here? What is the approach? Let's consider, let's do one thing. Let's consider the first one. It will be easier, right? So let's consider the first example here. Let me do one thing. Here we have already written the approach here, right? So this one, this is fine. We are considering this example itself. First, what we will do, 5 will move right. As I've said, 5 will move right. And what we'll do before this one, before discussing this one, we will be going with the approach stack. So we'll be going with a stack approach, stacks, right? So we'll be going with the stacks approach. Just keep this in mind. So 5 moves right, and this one 5 moves right. First element let's consider here, this one 5 10 and minus 5 we have. 5 moves right. So what we'll do, we will push 5 to the stack. Easy, right? So 5 moves right, so first we will push the 5 to the stack. So then we have the number 10 here. 10 also moves right. 10 also moves right, so then we'll push the 10 to the stack as well. Now what we have in the stack, 5 and 10. Then we have 5 and 10 on the stack. So we are left with the minus 5. We are left with the minus 5. Now minus 5 moves left. Minus 5 moves left. Now we have to check the collision with the top. Top stack first in, I mean last in first out. Last in first out. Right. So here the 10. So the top of the stack we are having 10. Right. So at the top of the stack we are having 10, right? So we need to check the collision with the stack. Basically we have here 10 5, right? So here what we have to do, we have to check the collision with the top, nothing but the value 10. So 10, again we are going with the absolute value, just remember this one, 10 greater than 5. So now we are checking minus 5. So 5 with 10, right? So 10 is greater than 5. So this one explodes. 5 explodes. Smaller value explodes basically. Stack remains, now in the stack remains 5 and 10. So stack remains 5 and 10. So this is smaller, right? Minus 5. 5 is smaller. We'll compare with this one with the 10. So 10 is greater than 5. In this case 5 explodes and we are left with 5 comma 10. So the final answer that we got here is 5 comma 10, which is equivalent to the this one, what do we call, the output that they have given for the example one. Very simple one, very easy to understand, right? You can just try it out, the same examples, example 2 and example 3 here in the same way that I showed. So this is how we'll be making use of the stacks, right? So this is how we'll be making use of the stacks, right? So I hope this part is completely clear. So I hope the approach part is completely clear. Let's quickly discuss the complexities before writing the code. So here in this case, what would be the time complexity and the space complexity for the code that we'll be writing for? That's what we'll be discussing here. So what will be the time, what will be the time complexity here? The time complexity will be big of n. Why it will be big of n? Because each asteroid is pushed or popped at most once. Each asteroid is pushed or popped at most once. We know this one by with the help of approach. Just we considered the same thing, right? So just we are done with the approach. After the approach itself, we are discussing the complexity. So each asteroid is pushed or popped at most once in the stack. So here the time overall time complexity would be quite obviously big of n. And what would be the space complexity for the code that we'll be writing? So the space complexity would be big of n as well. Why? Because stack might hold all the asteroids in worst case, right? It stack might hold or stack may hold all the asteroids in worst case. So the overall space complexity would be big of n as well. So the time complexity and the space complexity for the code that we will be writing in the future would be big of n. Just remind this one. Remember this, right? We are done with the complexities part. Now we are completely familiar with the approach and the complexities. As we are completely familiar with the approach and complexities, we are good to write the code. Let's start writing the code. Right. So first, what we'll do, let's make use of the array deque. Till now, we have made use of the standard stack. Right. So and now we'll be making use of the array deque for the stack. Right. So let's go with the deque integer. So here this will be variable stack. So this one new array deque. This is fine. This is fine. I hope this is clear. So the next step here is let's go with the iteration. We have to consider individual asteroid, right? Let's go with the or let's move on with the iteration part here. This one will be asteroid of asteroids. So within the for loop, what we will do? So let's consider initially let's consider the variable destroyed and let's initialize this one to the boolean value false, not true, sorry. So let's initialize this one to the false. Right, after initializing the destroyed variable to the boolean value false, we have to handle the collision only if the current is moving left and top of the stack is moving right. Right, so this is the condition. If both are moving in the right, we cannot consider that one, right? We have to handle the collision only if current is moving left and top of the stack is moving right. So let's write the while loop. This has to be true at any cost. So that is the reason we'll be making use of while loop here. So this one will be stack dot here is empty. So end. So this one will be asteroid less than 0. So and this one again stack dot this one, let's do one thing. Let's make use of the peak last here. Peak last, if it is greater than 0, then what we'll do within the while loop, so let's initialize the top to peak last. I mean stack dot peak last. So here let me do one thing. So we can write the code in this way: top equals stack dot. So let's make use of the operation peak last so that the this one deque provides, right? So this is fine. So next condition is if top is less than or equal to negative asteroid, means positive and the negative value we have to consider. So, and we have to make sure that this is what do we call, we get the absolute value as output, right? So if top is less than negative asteroid, then stack top of the stack, the element that is present at the top of the stack explodes, right? The smaller element explodes. That's what they have given in the question. If so, we have considered this one multiple times. If top less than negative asteroid here minus asteroid, then the element present at the stack top or top of the stack explodes. Asteroid must still collide further, right? So here in this case, so I'll just make use of pole last pole last operation that the deque provides. So this is fine. This is fine. So let's go with else if here. Else if. So when I say else if, else if we are checking top equals minus asteroid. Top equals minus asteroid. So if both are equal, both should explode. Both should explode, right? So here, how can we articulate the same thing in the form of code? So I can just write here stack dot pole last. So this one I'm speaking of. The next line is destroyed. Destroyed equals true. So this one we are setting now. Destroyed, both the values has to get means both the asteroids has to get this one destroyed, right? In this case means we have to remove both the values from the stack. So destroyed, let's set this one to the boolean value true. Then the final step is we have to stop here. So let's make use of break. We have to break out of the while loop, right? In such case both the values, this is nothing but second this one second example, this edge case we are considering, both the values are equal, right? Then they meet at certain place, and they both explode, right? So this one, line number 12 to line number 15, right? Line number 12 to line number 15, else we are left with uh, only the current asteroid exploding, right? So here in this case else we will set destroyed equals true, and then finally we have to break out of the while loop. So I'll just give break here again. So this is it. Next, let me come out of this one entirely. So if nothing is destroyed, if no asteroid is destroyed, then just give me a second here. Yeah, if no asteroid is destroyed here, then we have to add that one, right? So here in this case add to the stack. So I'll just go with stack dot add last property that I'll make use of from the DQ. Let's pass the asteroid here. This is fine. I hope this part is clear. Let me come out of this one entirely. So we are left with the final step. We have to convert the final stack to the array. So we have to convert the final stack to the array. We need to consider this one in the form of array, right? So we have to convert final stack to the array. So how can we do that? So let me quickly write this one array. So let me consider result variable. This will be new int of stack dot size. Stack dot size here. This one is fine. Stack dot size. So int I equals 0. Let me initialize I equals 0. Let's go with a simple for loop here. Int val of stack here, this one result of let me result of I plus plus this one, let me initialize this one to the value. This is fine. Let me finally return the result. I hope this is clear. We are just converting the final stack to the array. That's it. So here, this is it for the coding part. This is it for the coding part. Whatever we discussed in the this one approach, that the same thing we have articulated in the form of code. That's it, step by step, right? So I hope the coding part is completely clear. Now let me hit the run button. I hope this works, man. I hope. Let's see. We have the error here. Error cannot find the symbol destroyed. We haven't initialized destroyed or what? So here we have, right? Destroys I have given here. Okay, destroyed. So now line number 17, same error, right? So now this has to run. Let's see. Now this has to work. Let's see. Yeah, now you can clearly see here the sample test cases are getting passed. So let me hit the submit button very quickly. So you can clearly see here all the test cases are getting passed. Means the code works absolutely correct in this case. Code works absolutely correct in this case. So whatever the code that we have written, I hope whatever the code that we have written is completely clear. I hope the solution part is completely clear mainly, right? Along with the approach and complexities that we have discussed earlier, right? So for now, this is it. Thanks for watching, guys.